My name is Carla Lara. I work in the development and technical support groups here at ChemStations, and I'm your presenter for this webcast. Our discussion of the sensitivity analysis tool will include how to access the tool, the concept of an active analysis, the chart options available in this version to visualize the results, the improvements made from previous versions, and a quick demonstration of these features using an example ChemCAD simulation. For those unfamiliar with sensitivity analysis, by definition, it is a tool used to automatically vary stream and unit op parameters over a defined range of values and record the results of each run. Sensitivity analysis is a very powerful tool. It can help us identify operating limits, find the variables that have greater impact in our process, and determine if a minimum or maximum exists when plotting a key result. In ChemCAD 7 and earlier versions, sensitivity analyses and their options were all listed in the Run menu. Running the analyses or plotting results require multiple clicks, and we repeated this process when using any of these commands. This complex structure has been replaced by the sensitivity group in the Analysis tab, where all the commands are now one click away. Every time we create a new sensitivity analysis, this analysis is added to the selection dropdown. And we can easily switch between sensitivity analyses by clicking the drop-down arrow and selecting a different analysis. Once selected, all the commands in the group apply to the active analysis. In sensitivity, we can visualize the results using three types of charts. A line chart is just an XY chart, where one or more recorded variables are plotted in 2 dimensions to show the effect of changing one independent variable. A surface chart is a new type of chart. One of the recorded variables is plotted in 3 dimensions to show the effect of changing 2 independent variables simultaneously. Different colors are used to indicate the relative highs and lows of the dependent variable. When the 2D projection option is checked in surface, the recorded variable is instead plotted in 2 dimensions to show the effect of changing the first independent variable for fixed values of the second independent variable. Before the implementation of the surface in this version of ChemCAD, this chart was the only chart type available for visualizing the results in ChemCAD 7 and earlier when varying 2 independent variables. And now another quick run through of the improvements to the sensitivity analysis tool in ChemCAD. Again, ChemCAD 7 and earlier, we used a single dialog to choose how to visualize the results. And it wasn't always clear which variables could be selected or how the chart will look like. In the next version of ChemCAD, once we've run the analyses, clicking the Plot Results command will prompt the Sensitivity Analysis Charts Options dialog. This new dialog greatly facilitates the selection of the chart type as well as the variables to plot on each axis. Another new, more advanced feature is the removal of unconverged points before drawing a chart. When using sensitivity to stress test the operating limits of a process, we might hit an infeasible operating point where the simulation fails to converge. Including these numerical outliers makes it hard to visualize the practical results of the analysis. So by unchecking the Show Unconverged Point options, we're able to remove the outliers from the chart and focus on the valid operating range of the process. Please note that this option does not remove the data from the report, it just removes it from the chart. And finally, as a result of rewrites to our calculation engine, we observed significant speed increases in many areas of the software compared to CHEMCAD 7, but particularly in sensitivity analyses. At least 40% faster depending on the complexity of the simulation and the computing power of the machine, with further increases observed when using the multi-core option. Analysis that used to take a long time now can be run in a few minutes, sometimes even seconds, which allows us to perform many more runs and obtain very detailed results. Again, for a quick demonstration of these features, we will look at a distillation process that separates benzene and toluene. As a starting point, we specified the number of stages and relative feed location, as well as the mass fraction of benzene in the distillate and the mass fraction of toluene in the bottoms. With these specifications, CHEMCAD calculates the product flows, reflux ratio, condenser and reboiler duties, as well as the capital and operating expenditures using mass and energy balances, but also sizing and costing routines and custom calculations to obtain a rough estimate of the total cost for this process. So we can then use sensitivity analysis to help us optimize the column design. We can vary either the number of stages, the relative feed location, or the product purities, and we can do that either one at a time or any pair combination. These variables are shown in green on this slide, and these are the independent variables. For each value of the independent variables, we would like to record the effect on the total cost, defined here as the sum of the capital and operating expenditures. These variables are shown in gray on this slide, and these are the dependent variables. So now that we have a better understanding of the sensitivity analysis tool, we're now ready to jump into CHEMCAD to do a live demo. The same simulation we had used before. Currently, we are feeding we're choosing the feed location to be much closer to the top. The current feed location is stage number 8, given the number of stages in the column is 32. So the first sensitivity analysis that would be interesting to try would be a change on this variable and record the effect of the total cost of the process. So from the Home tab, we can locate the Analysis tab and then locate the Sensitivity group. If there are no studies available or pre-made for this simulation, this is how it would look. This is also how it looks when a simulation that does have some analyses is first loaded. But just for demonstration purposes, the way to go about creating a new analysis from scratch would be to click on the Create New command, type a new name for the analysis, click OK, and use the Edit Sensitivity Analysis dialog to specify the independent variables in the Adjusting tab, and as many as 12 dependent variables using the Recording tabs 1 through 4. Once these specifications are complete, we would click OK and run the analysis. For purposes of this webcast, I've already made 3 different sensitivity analyses. We're going to start with the one that is changing the relative feed location by keeping everything else in the flowsheet constant. By selecting the analysis, I make this my newly activated analysis, and I can click on the Edit command to review the specifications. So for this analysis, I'm changing the relative feed stage, which is a value in the controller unit upstream of the column, and recording the total cost of the process, which is carried out as a custom calculation in the parser unit operation ID 100. So this is a single independent variable analysis that records a single dependent variable. Once I have specified my analysis, I can hit Run All. It goes very fast, as you can see. And then to visualize the results, I can go and hit on Plot Results, where I can choose the variables to plot on the y-axis and the variable to plot on the x-axis. Because this is a single independent variable analysis, the best way to visualize the results is to do that in a two-dimensional XY chart. After I've done my customization at this level, I can hit OK and generate a chart that makes it really easy to identify an optimum feed location, and that location is around halfway through the column. With that in mind, I can close the chart, close the report that gets printed with it, and utilize this newly understood information about my process by updating the value in my feed-forward controller so that it uses the optimum feed location. Click OK. To rerun the flowsheet after I made a change, I could go back to the Home tab, or just more easily, just hit Run All from the Quick Access toolbar. Another analysis we could do is to analyze the change on the total cost as we change the number of stages in the column. Again, by keeping that relative feed location constant around halfway through. Such study is a vary number of stages, which can be specified as follows, where the number of stages is being changed from a very small number to around 35 stages in 30 equal steps, meaning the spacing in between is an increment of 1, and that is because the number of stages have to be a discrete variable. In the recording page, I'm recording all the economic variables that are calculated on my flow sheet with the objective to minimize the total cost. And on the second recording page, I'm also recording the actual reflux ratio as calculated by the SCDS unit operation as I'm changing the number of stages. When I run this study, I get a report right after the run. This is a new feature in this version of CHEMCAD, where as soon as you finish a study, if there are any unconverged points, we will let you know in the form of a report. And we can clearly see here that at very low number of stages, the column fails to converge. That separation is not feasible below a number of stages equal to 10. So as I close the report and choose plot results, I'll be interested in seeing how that shows in my chart. So I'm going to show those unconverged points and click OK. And as mentioned before, showing all the unconverged points on a chart can make it very hard to isolate what's real data and what's infeasible data. So instead of looking at this section where the column is failing to converge, I'm going to go back to the simulation and redo the plot, but this time I will uncheck the option so that those outliers are removed from my chart. Closing. So now that I've generated all this data, there are many ways in which I can manipulate it to show different relationships or even different charts. So I don't have to run this again, but I can go back to the plot results, or maybe I will run it again just by editing, maybe making sure I'm not going into very low values of number of stages. So I can adjust the lower bound of my analyses, change the number of steps to keep those values as integers, and rerun the analysis. Once I've rerun it, I can go to plot results, and instead of showing that relationship between reflex ratio and number of stages, I would like to show all the economic variables as function of the number of stages. Click OK. And because these variables have very different values, plotting them on the singular y-axis makes the comparison among them very hard to make. So one thing we could do at this point is assign a few of the variables to another y-axis. I'm going to place the capex on the secondary y-axis and the opex in the tertiary y-axis. And rescaling the data like this allows me to quickly identify that the number of stages that minimizes the total cost for this process is 20. Now, of course, there are different ways in which we could infer the same information. And one thing you can also do by going back to plot results is change the variable that is being plotted on the independent axis. So just like number of stages is changing, reflex ratio is changing, and I can regenerate the data using an equivalent way of just visualizing the same data in an equivalent way, but maybe I'll be able to show different relationships. So just by quickly changing the variable on the x-axis, I can regenerate the data, assign to the other axis again, and see that although these charts show the same information, the way in which I'm showing it does change depending on how I've specified the plot. There is, of course, a lot of customization of the labels that we could do, but that is outside the scope of this discussion. So to finalize this section of the webcast, I'm going to close all charts, close all reports, and put these two sensitivity analyses together. So instead of changing one, keeping everything constant, and then do the other one, I could simultaneously vary the number of stages and vary the feed location. And I have such study defined already, where my first independent variable is the relative feed stage, and my second independent variable is the number of stages. I'm again recording the same economic variables of interest, and I can hit run all and observe that as we are incorporating a more complex analysis that takes way many more runs, this is still doable given the speed increases that we see for this next version of CHEMCAD. So doing over 200 runs of this flow sheet took around 11 seconds on a very standard 2-core machine. After the analysis has run, we go to plot results, where by default, we will be given the choice to show and visualize our results as a surface. So having the two independent variables in the X and Y axis, I can then show what the effect is on the dependent variable total cost. Clicking OK. I see the surface that has the relative feed stage in the x-axis, number of stages in the y-axis, and the total cost on the z-axis. Using the rotational controls at the top, I can rotate the chart to the right. I can rotate it so I can look from above, and I can even zoom in to, by eye, guess that the optimum is around this location. As mentioned before, you'll see a color map on the right-hand side showing you the relative values for the dependent variable, blue being a lower value and yellow being a higher value. You can also zoom in and out using your scroll wheel. And there is further customization that can be done on the labels as well as the axis grid lines. If visualizing the results as a three-dimensional surface is challenging, we also have the ability to redo this plot as a in its two-dimensional form. I can do that by going to plot results and checking the 2D projection option and hitting OK, which will show me the same information, just like this time I have different curves for different fixed values of the second independent variable. With this chart in its XY chart mode, I can right-click and draw a rectangle, maybe zoom in even more, and easily identify that the optimum column design for this separation is number of stages equal to 20, with the feed stage entering at stage number 10. So once I have this information from sensitivity, I can close all the charts or save them and update my column to reflect the optimum number of stages, optimum feed location, go to the Home tab and rerun the flow sheet and save the flow sheet in its optimized state. This concludes our discussion of the sensitivity analysis tool in CHEMCAD. So to recap, the webcast covered the new and enhanced features for charts and sensitivity available in the next version of CHEMCAD. In the first half, we showed how to find, generate, and customize charts using the available features in the contextual tab. In the second half, we showed how the changes to the user interface, the chart engine, and the calculation engine have allowed us to unleash the potential of our sensitivity analysis tool, making it easy to run and visualize complex analyses in a reasonable amount of time. We thank you for attending this webcast, and please stay safe and healthy.